Hello everyone. Today we will examine another example of magnetic circuits. We have two-letter U magnetic core and there are two air gaps between these U parts. So let's start to draw magnetic circuit according to given figure and the properties. So we have only one winding. So because of this, we have only one source in the magnetic circuit representation of this figure. And the source value will be N times I, which is the magnetomotive force according to number of turns and the current which we applied to the winding. Then we have to examine our circuit in according to cross-sectional areas and the permeabilities. So when we examine the figure, all the widths are equal to each other. They are 10 centimeters. So because of the cross-sectional area differences, we don't need to separate any reluctances. So because of this, I will use one reluctance to represent the core part. But because of the permeability differences, we have to use one more reluctance to show the air gaps in the figure. Okay, let's start with the R core reluctance calculation. For R core, we will take whole core part for the figure. So R core, our general equation is L over nu times A. So we will take the core part mean path length, core permeability value, and the cross-sectional area is same for core and the air gap, so it can remain as a single parameter. For LC, what we have? We have a square magnetic core. So let's take, to simplify, only one leg, then multiply by 4. So for the right leg, for example, we have 10, 50, and one more 10 at the corner. So for the corners, we will take half of the dimensions. So because of this, 5, 50, and one more 5 for the below corner, half of 10, must be converted to meter. And we have 4 legs for this figure. And in addition to that, we have to subtract the air gap lengths. So we have 2 10 to the minus 3 because of the millimeter unit. For the denominator, we will start with the permeability, and permeability includes relative permeability and the free space permeability. So relative permeability is 800. Free space permeability is a constant, which is 4 pi 10 to the minus 7. For the cross-sectional area, for the core part, if we check the widths, as we said, it is equal to 10 centimeters, and the depth is also 10. So 10 times 10 must be converted again meter square. Okay, from here, our core will be equal to 239 kilo ampere turn over Weber. And for the next one, our core, after our core, we can calculate the air gap reluctance. And we will use air gap length and new air gap and the cross-sectional area. So we have 2 times 1 millimeter air gap length totally in one loop. So because of this, 2 10 to the minus 3 divided by, for the permeability of air gap, relative permeability will be 1. And the new 0 again will be 4 pi 10 to the minus 7. And we have same cross-sectional area according to this figure. 10 times 10 must be converted to meter square. So we have 159 kiloampere turnover Weber as air gap cross-sectional area. Now the total reluctance, equivalent reluctance according to the circuit can be determined. It will be our core plus our air gap. We have two series connected reluctances and it is equal to 398 kiloampere turn over Weber. Now we can focus on the question, which is if the flux is 12 milliweber, if we want to produce 12 milliweber, how much current we must apply? So the current will be flux times reluctance over number of turns. And the flux, which is 12 milliweber, our equivalent is calculated total reluctance 398,000 divided by N 500 turns. So we need 9.55 amperes to be able to obtain 12 milliweber inside the core. Thank you for watching.